Welcome to the 10th lecture on module 2 on HSE practices in offshore engineering. We are talking about lectures on module 2 where we are focusing on operational safety. Today in the 10th lecture we will talk about something more detailed on accident analysis. Let us quickly rewind and see what we have discussed so far in the last lecture. We have understood that risk need to be addressed with an emphasis to economic losses. Human loss can also be one of the part of risk assessment, but economic loss is also vital, it should be addressed. So, Frank and Morgan method in early 80s, basically 79, is a simple, efficient and practical tool to perform risk assessment on process industries, the objective of this method was to reduce the potential loss. The essential goal is reduce potential loss by identifying the important contributor within the plant, while the crucial department within the plant will be taken care of because it has got potential of high risk. This method also helps safety executives, HSE executives, to pay attention to those departments that are crucial. Morgan's method is considered to be one of the best employed tool for addressing such problems as seen in the literature, and possibly one of the easiest method to attempt financing risks as stated by David and Williams, 2007. So, it is one of the easiest and simplest method to address financing risks. Now, let us talk about some more definition and understanding on accident process. Let us say my objective is to defeat the accident process. At the first place, I do not want the accident to happen. What are the different steps that can be taken or considered during an accident? Let us say an accident occurs due to initiation, propagation and can be controlled with termination. Initiation is an event which starts the accident. So, it actually starts the accident. In general, it is always advisable and recommended that this activity or this event should be diminished to avoid catastrophic consequences. How this can be done? This can be done by various techniques. Various techniques by which this initiating event, if at all accident is going to be initiated, can be controlled or put down, can be used to achieve this objective. Could be what we call as grounding, inerting, maintenance, proper maintenance or routine maintenance, improved design, and you can also do it by capacity building, that is continuous training offered to the safety personnel to avoid human error. Next one is the propagation. Propagation is actually the event that expands the accident. Initiation is one which starts the accident, but propagation is one which is carrying it forward for a longer duration. As desired, these events should also be diminished. Some of the procedures by which you can control the propagation can be, some of the procedures by which you can control propagation could be, you can always plan for by planning emergency material transfer, because you know in most of the cases the accident occurs only when the material stock is available in the place. So, plan for an emergency material transfer, always try to have only fewer inventory of chemicals. Do not stock large volume of chemicals in the workplace. It is always advisable to use non-flammable construction materials, nowadays you see the top sides of offshore platforms, which are essentially and increasingly becoming composites, do have a temperature withstanding characteristic or fire resistant design characteristics. So, let us use or plan to use non-flammable construction material, then also plan to install emergency and shutdown installation valves. So, these are the methods or procedures by which one can always control the propagation, which is nothing but the expansion of the accident. The third one could be the termination. Termination is actually the event that stops the accident. So, the word terminates refer to stopping. For a better design, this should be increased for better and effective control over the accident. Some of the procedures by which this can be done. Could be end of the pipeline control measures, wherever you have the flanged end or a dummy end of the pipeline in a given process line, end control measures should be very carefully designed. Firefighting equipment in place, third could be relief systems, and lastly sprinkler systems. Friends, we have been talking about the risk assessment in offshore industry. We also said in the beginning of some of the lectures that offshore structures, or let us say offshore industry in general by and large, has something called a pre-declined acceptable risk. So, what is an acceptable risk? In offshore industries, we all now agree, at least to some extent, risk cannot be avoided. You cannot avoid risk. You cannot make certain zones zero risk zones. Certain zones on petroleum industry cannot be made as zero risk zones. Let us see what are they. Drilling, exploration and production. These are the areas where risk will be present implicitly because of the nature of the process. And we all agree to some extent, in fact to a larger extent, that there are many inherent factors which lead to unforeseen incidents which subsequently become accidents. So, depending upon the environmental conditions prevailing, these incidents mature to become accidents. It is therefore important to realize and understand that risk should have a level of acceptance in offshore industry up to a pre-acceptable level. So, let us say according to regulatory norms, risk is acceptable and permissible in offshore structures. So, all regulatory norms accept, rather permit, risk to certain level in offshore industry. Let us quickly see what are they. The first and foremost agency which is popularly practiced and accepted globally is Environment Protection Agency, EPA, United States. According to this, by definition, EPA states that risk in 1 million is acceptable if this risk is originated from carcinogens. For non-carcinogens, hazard index is calculated and if the value is lesser than 1, it is acceptable. That is an acceptable risk. by EPA. Now, the next agency which is also recommending acceptance level of risk is the United Kingdom Health and Safety Executive. According to this, any fatality accident rate which is equal to unity or lower than that is acceptable. One can ask me a question, is actually risk involved only in offshore industry or any process production or any mechanical industries? The answer is very interesting. In fact, we have risk indicators even in routine part of life. There are different fatality statistics available for common non-industrial activities as given by Lees in 1996. As given by Lees in 1996, there are fatality statistics of non-industrial activities. Let us say what are they? Let us say what are the activities and what is the FIR in terms of deaths per 10 power 6 working hours of exposure even staying at home, I mean without doing any work, non-industrial, domestic, still it has a FIR of 3. That is, if you continue to stay at home, wherever you are exposed to 10 power 6 working hours by staying at home, for that kind of exposure, still 3 people would die. So, fatality accident rate could be 3. Travelling by car, FIR is slightly higher, it's 57. Travelling by cycle is a day-to-day activity, FIR is higher still, 96. Travelling by air, FIR is still higher, 240. Travelling by motorcycle, still higher, 660. And rock climbing, which is one of the mountaineering exercise which people do for physical fitness, this has got the highest FIR, which is 4000. All these are non-industrial activities, still they have a fatality accident rate. So, there is no exemption that an oil gas industry which deals with high degree of hazardness have also an acceptable fatality accident rate. Interestingly, let us look at this table and ask a question which you need to answer. Let us say the table shows, as said by Lees in 1996, travelling by air has got a very high fatality accident rate compared to that of travelling by that is a cycle or travelling by car. So, do we really say that travelling by air is risky, because the fatality accident rate is much higher compared to that of travelling by cycle or travelling by car. But however, we generally hear in the news and we see from the media that road accidents are very common, however, air accidents are not that common, at least in any parts of the world. So, but the figure shows, do you think it is a reverse concept that travelling by air is having a very high fatality accident rate compared to that of driving on road by a car? The answer is not. Please look at this figure. Travelling by air has a very high FIR, but remember, if a travel by air equivalent to 10 power 6 working hours of exposure, then only this will happen. But however, if you want to go from a place of A to B, whatever may be the distance between A and B, if you travel by car, it may take about let us say 20 hours, whereas if you travel by air, it may take about let us say for example half an hour or 1 hour. So, the exposure time is very short compared to air travel. However, fatality accident rate or the risk involved in air travel is much higher compared to that of a road travel. But since you are exposed for longer duration, maybe 20 hours, 24 hours of that event, even though your FIR may be lower depending upon the statistics shown in this table, but your risk exposed to the condition is much larger. Okay? So, that is how it has got to be defined. So, we need not simply take this number and try to get confused that okay, travelling by air has got a very high FIR, in fact rock climbing is 4000. So, we should not climb rock at all, no mountaineering at all, that is not the idea. You have to not only look into the number, but look into the denominator of the number, that is you need to expose yourself for 10 power 6 working hours of flying if you really wanted to enjoy or really wanted to foresee a 240 FIR against this. Whereas, if you drive car for 10 power 6 working hours, your FIR is only 57. Okay? So, that is the idea. Let us say after briefly understanding the accident analysis techniques, let us talk about risk assessment, which is very vital and very interesting and very necessary for an offshore engineer or safety executive to know. Risk assessment can be two forms. You can also do it qualitatively, you can also do it quantitatively. So, risk in general refers to a situation and a recognized hazard. So, prior to risk assessment, you should do hazard identification. So, hazard identification is need to be done prior to risk assessment. Why? Because risk assessment by definition needs recognized hazards to be identified prior of that. Quantitative risk assessment, which is also QRA, involves in estimating both the magnitude of the potential loss and the probability of occurrence of that potential loss. So, basically risk in terms of QRA, that is quantitative, is a product of magnitude of the potential loss multiplied by the probability of occurrence of that potential loss. So, the moment I say magnitude, intelligently now we will include the economic losses also, not only the fatality. Now, the risk evaluation deals with the events and therefore, it is qualitative. Risk is also identified by continuously observing the changes in risk parameters. So, risk identification is observation made continuously on the changes in risk parameters. So, it is very important that the risk parameter changes should be monitored continuously on the existing process, and therefore, risk identification is a continuous process, whereas risk estimation is done by determining the probability of occurrences of the event and the magnitude of the consequences, which is post processing of the data identified during risk identification process. So, risk estimation follows risk identification. It is purely quantitative. It works on the data which is been prepared during the risk identification. Risk evaluation deals of course with the events and is a qualitative approach. So, therefore, risk evaluation consists of risk aversion and risk acceptance. Therefore, risk assessment consists of two stages. Stage 1, risk determination. Stage 2, risk evaluation. Risk determination deals with the numbers, and therefore, this is quantitative. Risk evaluation deals with the analysis in terms of the comparison, therefore, this is qualitative. That is what we said here. So, risk assessment can be both quantitative and qualitative, because it deals with two stages. One is the determination, other is evaluation. Let us slightly look at risk evaluation in a better form. Risk evaluation consists of risk aversion and risk acceptance. We already said that here. Risk aversion, it consists of risk aversion and risk acceptance. Risk aversion is determined by the degree of risk reduction and risk avoidance. Whereas, risk acceptance is establishing risk reference or is based on risk reference and risk reference. What are risk references? Risk references are for comparing the values, or meant for comparing the values. Risk referents are actually standards with which the risk parameters are compared. So, now National Academy of Sciences identified 4 steps for chemical risk assessment. Please understand, risk assessment has got 2 stages, determination and evaluation. One is quantitative, other is qualitative. Risk evaluation has got risk aversion and acceptance, whereas aversion is based on the degree of risk reduction you adopt and the risk avoidance policy what you have in your company or in your plant, whereas risk acceptance is purely based upon your reference and your reference. So, it all depend upon what do you call as a referent to compare risk. So, therefore, acceptable level of risk or risk acceptability can be dynamic. It can vary from company to company, can vary on the same company from country A to country B, because it is all depending upon under the global act of that particular region where the company or where the oil and gas company is located or the express unit is located, what are the risk reference the global standards are referring to. It may always vary. So, therefore, the norms for risk acceptance can vary from one country to another country, though both the countries have the same potential oil and gas company who is doing exploration. So, for chemical risk assessment, the moment I say chemical risk assessment, it is very clear that we are talking about assessing risk for people or for the plants which are exposed to chemical. Okay. There are 4 stages involved in this. One, first stage is the hazard identification, second stage is the dose response assessment, third stage is the exposure assessment, and fourth stage is risk characterization. Which we will discuss in detail in the next lecture. So, in this lecture we talked about accident processes, accident analysis. We also learnt different terminologies involved in risk evaluation, assessment, identification. We also said why hazard identification preludes risk assessment by definition, and we have now understood to some extent that acceptable level of risk can vary from country to country, from company to company in the same country, depending upon what are the risk reference the company or the global standards are using and what are those references which you are comparing for risk assessment parameters. I hope you are following the lectures. I want you and I will request you to follow all the lectures regularly, keep on revisiting them and hearing them continuously. Thank you.